Assalamu alaikum. We are starting our class. This is another class on electric field. Please copy the year number. Ideally, try to look the question in your past paper book, whatever book you are using, and try to solve it in your own book. So I have done the first part, which is the definition of electric potential. This is June 15, paper is 42.5. Define electric potential at a point. Potential at a point is the work done per unit charge to move a unit positive charge from infinity to that point. Two positively charged metal spheres A and B are situated in a vacuum as shown. Point P lies on the line joining the centers of the two spheres in and is a distance x from the surface of sphere A. Read the question. The people who have just joined, they should note that it is June 15, 42.5. You have to read the question. There are 2 spheres, sphere A and sphere B. And point P lies on the line joining the center of the two sphere and is a distance of x from sphere A. Now, first part was simply electric potential. He says that this is the case that the object is, the distance is taken from sphere A. The point P lies on the line. The variation with x of the electric potential due to the two charged sphere is as shown. Now look at the graph. It's voltage against distance graph. Look at the graph. It is voltage against distance graph. V upon x is the gradient. State how the magnitude of the electric field strength at any point P may be determined from the graph. Now you have to tell examiner that this is voltage against X. And you know the formula that E is equal to V upon X, which means it is the gradient. So you will tell the examiner that you have to find the gradient. Read the next part. Without any calculation, describe the force acting on a positively charged particle placed at point P for values of x is equal to 0 till 10. 0 till 10. Look at this graph, 0 till 10. If I move from 0 till 10, I will see that voltage is decreasing, decreasing, and it reaches a minimum value, but then the voltage begins to increase. And then the voltage began to increase. How I have already told the examiner that the gradient is electric field. Now, do you people remember that? Is there any relation between electric field and force? I want to recall this formula. E is equal to F upon Q. It means E and the force are directly proportional. And it means that I can say here that the gradient is directly proportional to the force. Gradient is directly proportional to the force. Now, if I draw a tangent, I will get the force. Now, I draw my tangents on different positions. I draw my tangent on different positions. Let me draw a tangent here. Look at the tangent. And let me draw a tangent here. And let me draw a tangent here. I have drawn three tangents. Remember, gradient is representing the force. Now you people have to tell me that where the force would be maximum and where the force will be minimum. Remember, when a line is parallel to x-axis, its gradient is 0. So now feedback is needed. Yes, you can answer me on the chat, and you can also answer me on the mic. Maximum at 0. Very good, because gradient is maximum. So here the force is maximum. What about T is equal to 6? Yes, 0 at 6. Force is 0, right? What about the last? T is equal to 10. Here you can see T is equal to 10. Force is negative. So we made our plan, we made our discussion, and we can write it here. T is equal to, I'm sorry, how come I got T? The tangent increases, the force increases, right? So this is the working, and as I advised earlier, that everyone should use their own past paper book, take out the year number and write in it, then it will be much better. The positively charged particle in B part 2 has charge Q and mass M given by the expression this. Then why you're asking for this AI assistant? Leave it now. We do not need any artificial intelligence. We are naturally smart. So why you're looking for AI? We do not need AI. The positively charged particle in B part 2 has charge Q and mass M given by the expression. Initially, the particle is at rest at the surface of a sphere A, where x is equal to 0. It then moves freely along the line, joining the centers of the sphere until it reaches the surface of sphere B. Mark with the letter M the point where the charged particle has its maximum speed. Now, this is a technical question. It's okay. No, actually, I asked, there is another student here. I think I'm not saying to you then, you do not need any AI, I know. So that was maybe by chance a button was pressed, but I was talking to some other student. A positively charged particle. Now, let us discuss C part 1 on figure 5.2. This is figure 5.2. The positively charged particle in B2 has charge Q and mass M. Mark with the letter M the point where the charged particle has its maximum speed. Now, where the particle should have maximum speed, we know the force, we know the electric field strength, but how we can engage velocity? How should I find the force is decreasing? The force decreases to 0 till it is 6. And then force increases from 6 to 10. And he says the object is reaching the surface of the sphere B. Now this part is tricky. The formula is, initially the particle is at rest on the surface of sphere A, where x is equal to 0. It then moves freely along the line joining the center of the sphere until it reaches the surface of B. Mark with the letter M the point where the charged particle has its maximum speed. Look at this diagram. The story is here. The charge particle is sitting here. The charge particle is sitting here. It moves from this position to this here, and it reaches the sphere B. Now he's asking that where the charge particle will have the maximum speed. Remember this, both particles are positively charged. Sphere A and sphere B are positively charged. And the particle which you are moving, look at this question again. The positively charged particle in B part 2 has this. This particle is also positive. So the particle which is moving is also positive. It will be moving towards the bigger sphere B. And look at the potential. Potential is decreasing. Potential becomes minimum, and then potential increases. I have given you the story. Now you can give me the answer. When the force is zero, acceleration is zero at 6. This is a possible answer, right? Very good answer. What is the logic for this answer? What can be the logic of this answer? Remember that he's asking for the speed where the particle has maximum speed. Remember this. When speed is maximum, it means acceleration is equal to 0, which means resultant force should also be 0. So that is why we can take a position 6. 6 is a suitable position because the force is 0. Use figure 5.2 to determine the potential difference between the sphere. Now, how we do that? It's only a 1 mark question. Determine the potential difference between the spheres. First, let me read I'm going to read from here, and it looks for me, for me 570. Now I want to read the other line. I marked here. So it looks for me 230, perhaps. It looks to me 230. So find the delta V. 230 and 570. Hmm, 340. Use your answer in 2, part 1 to calculate the speed of the particle as it reaches surface of sphere B. Now I have the potential difference. He wants me to calculate the speed. I have used this equation. Work done is equal to change in potential energy. Oh, sorry, change in kinetic energy. Now they have given me the charge. I know the potential, and I can take the final velocity. Initial velocity is 0. Initially, the particle is at rest. So I will take u is equal to 0, and I have delta v is equal to 340. And also I have q upon m, 4.8 into 10 to the power 7. I have moved the m on the other side. Now solve this and let me know the answer. One point eight 10 power 5. This is my next paper, November 15, 41.5. And let's have a quick 5-minute break for namaz. And I am coming back in just like few minutes. And any one of you wants to say namaz, also the person can say namaz. We're having a quick break. We are doing November 15, 41.5. A charged particle P is situated in a vacuum at a distance x from the center of a charged conducting sphere of radius r. For the particle P outside the conducting sphere, you can assume it as a point charge. State Coulomb's law. Coulomb's law says that force between two charged particles is directly proportional to the product of the charges and inversely proportional to the square of the separation between the charges. The sphere and the particle P are both charged positively. State the direction of the force acting on particle P. As discussed here, the force will be towards the right, and where the force will be maximum, at the surface of the sphere, the force will be maximum because it will be closest to the sphere. Determine the ratio force on particle P at x is equal to r and at x is equal to VR. Now we need discussion on this part, how we can apply the formula. Should we go for Coulomb's law? Force on particle, we have a formula that force is inversely proportional to x square. So I can make it an equation. Force is equal to k upon x square. If I make a ratio, I can say F1 upon F2 is equal to x2 upon x1 whole square. Look at this. Now this is a simple working. The ratio is coming 16. When the charge on the sphere is 6 into 10 power minus 7 coulomb, the electric field strength at the surface of the sphere is this. Electrical breakdown, a spark occurs when the electric field strength at the surface of the sphere exceeds 2 into 10 power 6 volt per meter. Volt per meter is electric field strength also. Determine the additional charge that may be added to the sphere before breakdown occurs. Now read this question. What is the formula for electric field strength? E is equal to K Q upon X square. So we can first try to find the value of X or R square, you can say. So I can rearrange it because I do not have the value of X. So I should go for a ratio method. First option is ratio method. And second option is the working by the approach. So I can go for a ratio method that the radius of the sphere is not changing. So I can make a ratio formula, which we used to do in always AS. E1 upon E2 is equal to Q1 upon X1 square upon Q2 upon X2 square. If you further simplify this formula, E1 upon E2 is equal to Q1 upon Q2, and then it is X2 upon. Now I can cancel out X because the two ratios are equal, because the object is at the surface. The object is at the surface of the sphere. So this is the formula now. We have the first electric field strength value 1.5 into 10 power 6 upon 2.0 into 10 to the power 6. And the first charge was 6 into 10 is to power minus 7 upon, I don't know the value of Q2. So you can now help me to find this value. Examiner says additional value. So how should I cover this word additional charge? Now see this working. So this question is completed, and we keep it up to here. And we will now, inshallah, continue this in our next class. Allah Hafiz.